I was watching a really nice history documentary series, Christmas Day, I believe. Or no, it was just before. Might have been Christmas Eve. And the this whole thing started that this person mentioned these ancient plaid um, fabric samples, um, and from the stuff I knew from before, one of them was found from these Indo-Europeans, the Tocharians, which is a very well preserved sample, and the wool of that material was researched and examined, and it was verified that the wool came from, it was a European source of wool. And the other sample um, of a very old preserved kind of plaid, although not in as great condition, but still, it's still quite visible enough. Was from the Hallstatt culture in Austria, and so this whole ancient kind of a blood memory, if you will, kind of revived something in me, and it made me think of stuff I had attempted to do before, and I went back to the geometry drawing board, and I ended up finding something. Um, so to start with, these um, symbols here, although they are used in many different ways now, and they have umpteen meanings depending on who you talk to. Um, but these symbols here um, are quite old, and the earliest, if not some of the earliest, if not the earliest ones that have been found, come from the Vincha culture, and then you find more examples of this in the Susutani culture and the Tripolini culture later in that, etc. Um, and they're they're between you know a symbolic script and an actual alphabetic script. So technically, there's like debates going on. Is this an actual alphabet or not? Well, the one thing you can say for sure, it is a symbolic script. And I also have come to personally believe that these are the original symbols from where the later developments of plaid and the specific pattern in plaid were derived from later. And it has to do with the knowledge of geometry advancing, essentially. And I will show you how the plaid pattern is actually encoded, if you will, with a very high knowledge of geometry. Um, so yeah, just to go quickly here, these are kind of like four of the ones out of all those symbols, and there's like 100 of them or something like that, if not more. But these ones in particular are important for this. And it's the plus sign in a circle, a plus sign in a square, and then you have the plus sign on an angle or an X, one in a circle, one in a square. And so that's what I started with. That's what I started to work with. And so I went and did this the old-fashioned way with a compass. And basically, you start with a straight line, and then you draw a circle, any size circle, and then you go from one point on the line to the edge of the circle, make a point there, make a point below, and you do it from the other side, and that gives you these two reference points, a North Pole and a South Pole, or your vertical axis, and you draw your straight line there, and that gives you 4 equidistant 90 angle quadrants. And then it's kind of like some basic geometry here, but like I said, I wanted to do this the old-fashioned way. And then you take your compass and you go to one of those points with your plus sign now on the edge of the circle, and you mark one mark there, one mark there, one going the other way there, and then you do them this way, that way, that way, and then that way, and that gives you your 4 corners for your square. And then of course then you can fill those in. Those you don't need, that you just need those to get that line there. You know, just this is just with a compass, right? I'm not using any kind of other kind of tools. And I'm going to pause here so I can flip the page. So, using that information, it's a little hard to see here, but the pencil there is the circle inside the square, and there's the plus sign, and there's the diagonals, and that's how you also get a perfect octagon. You draw a circle and square it, and you put your plus in the diagonals, and that gives you those points to fill in your a perfect octagon, which fits inside the square and the circle. And let me see if I can remember what else I did here. Right, and then you draw, when you get your points, this is why you need the octagon. When you get your points for your octagon that are not on the edges of the square, where the square and the circle meet, those points here, and you draw your lines connecting those points. Those points, and then that gives you that line there, and then if you measure from the center, and then you draw a diagonal from the center to that point there. Okay, and then that gives you this distance here. And that distance you measure from the center up there, and you mark it there, and you do this on all sides, and that gives you the measurements for another circle, which, interestingly enough, it's another squared circle. And I did a video on this before, and I found out that the angles where the squared circle points meet are 36 degrees. And this just happens to be exactly 36 degrees as well. So this is just an extra little tidbit here. You also get a squared circle from using this method. And then when you have these points, this distance here, you mark from the center to there, the center to there, the center to there, to there, center to there, center to there, center to there, the center to there. And then if you connect those lines, you get this configuration, which very much resembles a plaid pattern. And I mean, there's different plaid patterns out there, but this one in particular, which looks quite familiar to some of us, I think it's probably like, um, I want to say the most kind of common one, but perhaps not. But anyway, I have a few plaid shirts, and a couple of them are this pattern, and that got me thinking. I'm wondering if the original kind of idea for the plaid actually came from here, and of course to match these exact geometric proportions as someone is doing the loom work can be a challenge, but nonetheless they're almost identical, you know, especially some of the earlier plaid patterns. And that led me to believe that this has been these ancient plaid patterns, within the pattern itself. It is encoding this ancient geometry, this advanced geometry. You know, from starting with a a basic geometry, it advanced to where we literally got plaid patterns. So, as I've mentioned in a couple of my other videos before, I think that the plaid patterns are, some of them, especially the ones like this, are authentic, meaning they are actually derived from advanced geometry. And oh great, now you don't want to focus. Okay, there we go. I put a date on there. It just happened to be, I discovered this, or perhaps I've rediscovered this, December 25th, 2023. So, you know, 3,000 to 4,000, and tack on a couple more thousand years later, I have rediscovered the secrets of plaid. Okay, so I covered that one. I hope that was understandable. It is a bit hard to make out what I'm doing here, so that's why I did a couple of the preliminary steps. And hopefully I haven't been going too fast. If somebody wants to pause and see what was he talking about, what was he doing. I'm hoping this is understandable enough. Perhaps you even want to teach your children about this, and maybe they can get one of these beauties and do some old-fashioned geometry and discover some stuff. Let's see here. I'm going to pause here for a second before I show just the plaid pattern in an expanded version. I'm going to show a couple things here. Here's a sample from the late Vinca period, which almost strikingly is almost identical to these patterns found on carved into megalithic rock in France, roughly near around the same time period. And it also has these very similar geometry going on here, just as a kind of an extra note here. Let me see here. Here's an example from King Midas's temple or tomb. It's got some similar kind of geometry going on there. And up here is an 8-pointed flower, which also has to do with this geometry. When you do the plus sign and the 2 diagonals, you get 8 points. And of course, I showed you the octagon in there as well. I just thought this is interesting because this one is really interesting. And this is another example from the Phrygian period, of King Midas, the golden king. Everything he touched turned to gold. This is a great example of this geometry here, and really very precise craftsmanship there as well. And let's jump over to the plaid. This is the sample from the Hallstatt culture. As you can see, a very similar pattern. And there is the one from the Tocharian example. And you can see a striking resemblance there of this pattern.